Good morning, students. So today we are going to start with the next topic of the same chapter, that is computer networks. Now today we are going to cover the evolution of network. How did this computer network come into existence? Now the evolution of network. In the year 1969, the US defense needed a sort of network for its confidential information to be passed from one place to another place, and their subsidiary agencies known as ARPA, which is Advanced Research Project Agency, they developed a sort of computer network which was capable of passing or communicating from one computer to another computer. This type of network was known as ARPANET. Now the main aim of this network was to connect different universities, the scholars, the scientists in the universities, and the US defense. Now people could exchange their information, and some sort of entertainment could also be done on this network. Now the popularity of this network grew very rapidly, and the people were very much enthusiastic about this new technology at that time. Till 1980, only America was using such a technology in which the computers were able to communicate with each other or exchange their information. In 1980, in America itself, a private agency known as National Science Foundation created or developed a new network technology known as NSF net, which was capable of handling much more computers and much more bulk of data. Now they made this technology public, and all the people who were researchers and wanted to use it academically, and some business houses, they made good use of this technology. Now many private companies, they started building their own network. Then they were all connected to the ARPANET and NSFNet to form internet. Now this form of network at that time was only confined to the US. But sadly, the ARPANET was shut down in 1990 due to non-funding, and then the government funding for NSF discontinued in 1995, and therefore this network, NSF and ARPANET, was shut down. After that, many private organizations had this technology to create the network, and they also came into the field, and they developed a new network now which is known as internet. And now it was global, not only confined to USA. Now coming to the transmission media or the communication channel. Now the main important thing which is used in a network is not only the computer or the hardware or software, but the communication channel or the communication media. Now this media is the link through which the computers are connected to each other. The media are of two types: the guided media, which contains wires and cables, and the unguided media, that is through air, in which the signals penetrate from one place to another place through air, water or vacuum in form of microwaves, radio waves and satellites. Then cables. Now there is a wide variety of cables depending on the requirement, speed, cost, affordability of a network. There are too many options which are available. Now the very basic form of communication channel that is used is the twisted pair cable, or it is also known as unshielded twisted pair cable, that is UTP. A little bit more advanced technology is the STP, that is shielded twisted pair cable. Then we have the coaxial cable. Then we have the fiber optic cable and then the unguided media, that is wireless networks. Now the unshielded twisted pair cable. Now the twisted pair cables has, as you can see in the diagram also, it contains many thin wires insulated by uh, uh, you know rubber insulation, and they all are shielded together in a plastic insulation. Now these wires, the disadvantage of these wires is that they are very susceptible to some interference, like electrical interferences or wave interferences, these types of interferences. But still they are very popular where the number of computers in the network are too less, or the area which is covered for the network is quite uh, small. Now we have the shielded twisted pair cable. The shielded twisted pair cable, that is also known as STP, has, as I mentioned earlier also, the UTP has its disadvantage that it is susceptible to radio and electrical interference. But the shielded twisted pair cable is, it has a shielding which can absorb these interferences so that the communication is smooth and fast. But the another disadvantage of this cable is that the extra shielding could make it more bulky. Now the shielded twisted pair cable is used on the networks which use the token ring topology. We are going to study about the topologies in the later on topics. Now the coaxial cable. Now the coaxial cable, as you can see in the figure, it is the cable which we use in the cable network or a TV network, that is the dish networks. Now the structure of the coaxial cable is like it has the innermost uh, structure has a copper wire, a thick copper wire in the center. Then it is surrounded by a thick plastic insulation uh, to protect these this wire. Now above the plastic insulation we have a metal shield to block any interference like radio or electrical interference, okay, from some electrical equipments or some sparkings. The outermost shield, provides the earthing or the ground to the cable. Now optical fibers. Now this is the most advanced wired technology as we have of now. The fiber optic cable, it contains of a center glass core surrounded by several layers of protective materials. Now in between the innermost layer of the wire is nothing but a glass, a reflection glass. It is surrounded by a protective insulation. It does. Now the main difference between the UTP, STP and coaxial altogether and optical fiber is that the technology used to transfer the information is light rather than signals or current. So now this technology does not get affected by any sort of interference. Now as we can see, light is the fastest communication medium. So therefore this communication medium is the fastest among all the communication mediums. Now this technology is used where very fast communication is required, bulk communication is required, and as the technology is very expensive, where there is no consideration or criteria about the cost of network. Now microwaves. Now we have moved to the wireless communication. Now microwave is an electromagnetic wave in the frequency range about 2 to 40 gigahertz. Now microwave is a direct line of sight transmission. It is also known as LOS transmission. That means the tower which is sending the information and the tower which is receiving the information should be visible or in line with each other. The microwave communication consists of transmitter, receiver and the atmosphere. Now one tower, when it sends the signals, it becomes the transmitter, the receiving tower becomes the receiver, and the carrier is atmosphere. In microwave communication, parabolic antennas are mounted on towers to send a beam to other antennas tons of kilometers away. Now these towers are not located very close to each other, but rather they are kilometers away from each other, but the carrier waves are such in frequency that they can travel hundreds of kilometers. Now the higher the tower, the greater the range. As the tower is high, the range is too much, and if the tower is low, its range is less because of the missing line of sight. Now a new network that we often see nowadays is a wireless LAN. A LAN, local area network without any wires. Now to avoid the you know mixing up of wires and untidiness of these wires, we can uh, we can we can connect our computers with the help of wireless technology, and this type of network is known as wireless LANs. Now wireless LAN use high frequency radio signals, infrared light beams or lasers to communicate between the workstation and the file server or hubs. Now we have a device known as access point, which is used to receive and send the signal further to the network. Now each workstation and file server on a wireless network has some sort of uh, transceiver or antenna to send and receive the data. As you can see very well in the diagram, there is an access point located in between and it has three antennas. Now the main purpose of these antennas is to receive and send the signals from one node to another node. Now for long distances, wireless communication can also take place through cellular telephone or technology Now, when we have a wireless LAN generally is confined to a limited area. But for long distances of LAN, that is local area network, we use a technology which we use in the telephones. That is the microwave transmission or satellite transmission. Now, this technology is used to connect the computers in the LAN at a larger area than a LAN. Now, the wireless networks are great for allowing laptop computers or remote computers to connect to the LAN. Now, again, this wireless technology is very helpful if we want a new connection to be set up in the network, a new workstation to be added to the network in case of like if you have a laptop or a mobile phone which could be connected immediately or at any time and disconnected at any time. Now, wireless networks are also beneficial in older buildings where it may be difficult or impossible to install cables. Now, in the new buildings, there is a provision of LAN, but in old buildings where we do not have any sort of provision of LANs, the wireless technique is quite helpful. Now, coming to internet. Now, internet, as we know, network is an interconnection of several computers. Now, internet is a interconnection of several networks or several LANs. Now, how does it work? Most computers are not connected directly to the internet. Now, the internet does not connect the computers directly, but the computers are connected to their servers, and the servers are connected to some other servers, and finally they are connected to form an internet. They are connected to smaller networks which are connected through gateways to the internet backbone. We are going to study the gateways and backbone in the coming topic. Now, gateway and backbone. Gateway is a device that connects dissimilar networks. Now, because have not studied the topologies till now, so that means the topology is basically how you connect the computers. Where is the uh, location of the server in terms of the network? That is main what topology is. So gateway is a device that connects dissimilar. Every network may use dissimilar or different type of topology to create a LAN. So now the gateway is a sort of technology or a device which connects several types of topologies at one place. A backbone is a central interconnecting structure that connects one or more networks just like a trunk of a tree. So a backbone is the total entire connection of the network, the devices which are connected in the network, that is known as the backbone. Now, how does internet work? At the source computer, the message to be sent is broken down into small parts called packets. Now, whatever information is sent over the internet, it is again broken down into small packets. All the information cannot be sent in one go. So it is broken down into small packets of equal sizes. Now these packets are given a serial number 1, 2, 3, so that when these packets are rearranged, they are arranged in their order. The message is delivered in the required order or the sent order. All these packets are sent to the destination computer. Now these packets are you know passed from the source computer to the destination computer. Now the destination computer receives the packets in random order. Depending on the size or the bandwidth of the network, the packets may be received at the destination in a random order. That means maybe packet 10 is delivered first, packet 1 is delivered last. The packets are reassembled in order to form in order of their number and the messages restored. Now these packets are again reassembled according to their numbers, and then it forms a message. How it functions smoothly. Now the what is what technology is used to form or break message into packets and then reassemble it at the destination. Now every computer connected to the internet uses the same set of rules for communication. The main thing involved in this is that we have universal rules for communicating over the internet. Now these set of rules are known as protocols. Now the communication protocols, we are going to study the protocols also in the later on topics. Now the communication protocol used by internet is the TCP/IP, that is transmission control protocol, and internet protocol. The transmission control protocol is responsible for dividing the message, that is breaking down the message into small packets and reassembling them, these packets, into the message at the destination. The IP protocol is the carrier of the address of the destination. That means it guides the packets to the destination workstation or the computer. Now, as you all know, on the internet, we are we can send any sort of multimedia files over the network, video files, audio files. We have a real-time chat. Real-time means at the same time. So this is made possible with the technology named as interspace. Now, what is interface? Interspace is a client-server software program that allows multiple users to communicate online with real-time audio, video, and text chat in dynamic 3D environments. Now, at any point of time, you can communicate with another computer in a real time with any sort of medium like audio, video, or text. Now, few terms other which are related to the networks, workstations or nodes. See, there are three terms which are related to a network: workstation, nodes, and terminals. They mean one and the same thing. These are the subcomputers which are connected in the network. Now, server is the master computer. Server is the master computer. As I told you yesterday also, server is the computer which governs and manages the whole of the network. What is the role of server? Server is used to facilitate the sharing of data, software, as well as the connected hardware. Now, another hardware which is required to connect to a network is the network interface unit. Network interface unit is a unit which is uh, installed or connected in a computer so that we can connect this computer to a LAN. It is a sort of hardware. So it is a device which is attached to each workstation and server. So a computer not having an NIU cannot be connected to a network. So it is mandatory to have a network interface unit to a network. Now helps to make connections within the network. As I told you, it is used to connect one computer to a network. Now each NIU has a unique number identifying it called node address. Now every NIU has a unique number in the same network. No two systems can have the same number or the machine number in the same LAN. Now NIU is also called terminal access point, or NIC, that is network interface card. Now each NIU is given a unique physical address called MAC address, or the machine address. Now every machine, every terminal in the network has a unique uh, you know address, which is used to identify a particular machine in the network. Suppose machine number 1 wants to send a message to machine number 5. So how will the server uh, be able to identify which is machine number 5? And that is with the help of MAC address. Now how data is transmitted across the networks? Now, to pass the data across the network, we use three types of switching techniques. Switching means when data is sent and on the other end the data is received. This procedure is known as switching. Now there are three types of switching techniques. First one, circuit switching. Second, message switching. Third, packet switching. Now, circuit switching. Circuit switching, now physical connection between the two computers is established and then data is transmitted from source to destination. If both the computers are not available at the same time to communicate, then we cannot have a circuit switching. The circuit completes only and only if the both computers are connected to the network and are in a state of communication. Now, when a computer places a telephone call, now the very common example of this circuit switching we can see in a telephoning. In a telephone, the circuit is complete only and only if the call is received at the other end. If the call is not received, then we do not consider it as a communication. So when a computer places a telephone call, the switching equipment within the telephone system seeks out a physical copper path from senders to receiver's telephone. Now, when we make a call, then nowadays we have wired as well as unwired, uh, you know, communication medium. So through any communication medium, one phone tries to communicate or establish a connection to the other telephone. And when the other telephone is picked up, then only the connection is established. It is also said an end-to-end connection between the computers before any data could be sent. So when one phone is calling another phone, and when the connection, you know, when the other phone is picked up, then only the communication can be achieved, otherwise not. Message switching. Now, in this type of switching, the source computer sends the data to the switching office, that is the server. It stores the data, the switching office, the server stores the data, and then it sends it to the other switching office, that is another server. Then it is sent to some other switching office, and this process is continued till it reaches the server of the destination switching office, and then this message is delivered to the destination. It is also known as store and forward technique. So one office passes the data to another office, and this path goes on and on till finally the message reaches the server of the last or the destination switching office. As you can see in the figure, the system like A wants to pass some message to the end system B. Now it goes to switch 1. Then if there is some line free at switch 2 or switch 3, whatever line is free, it is further passed and then it reaches the finally the end system, that is P. Now packet switching. Now packet, as we have studied also, packet is, breaking up a large information into small chunks of information known as packets. Now, according to the bandwidth medium of the network, the size of the packets may vary, right? So there is a limit, because generally the packets are of equal sizes. As you can see, the second, a fixed size of packet is specified according to the bandwidth, according to the speed that is coming over the network. The size of the packet is determined, and likewise then the packet is formed. Now, all the packets are stored in the main memory in the switching office. Now, switching office means the sender. The sender of the information stores the packet in the switching office, stores the packets in the main memory, and whereas in the message switching, the packets are stored on disk. Now, this increases the performance as access time is reduced. Now, whatever, as we know that whatever is stored on the RAM is quite fast than whatever is stored on the disk. It is quite accessible by the fast. So that is all for today. I hope you got a good information on the topics which we have discussed. Tomorrow again we'll be back with some other topics. Thank you very much.